Hey everyone, and welcome. Today we're going to pull back the curtain on one of the coolest, most powerful ideas in all of programming. Seriously, it's a tiny piece of code that is secretly running almost your entire digital life.
So let me ask you a quick question. What in the world does a train, your social media feed, and your browser's back button all have in common? I know, it sounds like the start of a bad joke, but there's a really clever connection here, a hidden secret they all share.
And that secret is a chain. Yep, it's that simple. It's this basic but powerful idea where each piece is connected to the one right after it. You know, a train car links to the next one, a post in your feed connects to the one you just saw, your browser history links this page to the last one. It's all just a chain. And today we're going to see exactly how programmers create this effect using code.
So how do you actually do that? How do you tell a piece of code, hey, I want you to point to another piece of code that looks just like you? Well, you use a trick, kind of like a magic mirror that lets a structure see a reflection of itself.
The official term for this is a self-referential structure. I know, it sounds super technical, but the idea is actually beautiful in its simplicity. Just think of it like a box. This box holds some information, but it also holds one very special thing, a little arrow, a pointer, that points to another box of the exact same type. Okay, so let's break this down. On one hand, you've got a standard box. It just holds data, right? A number, some text, whatever. But our magic box, this self-referential one, it does two jobs. It holds its own data, and it holds the address, the location of the next magic box in the chain. And believe me, that one little pointer changes everything. And here it is. This is what it actually looks like in C code. We're creating something we call a node. That first line, int data, that's easy. That's our data box. But the second line, struct node link, that's the magic mirror. That's a pointer, and we've named it link. And what's it designed to point to? Another struct node. It's a structure that knows how to find a copy of itself. So cool. All right, so we've got the blueprint. Now let's actually build something. We're going to create our own little two-link chain using this exact code. Let's do it step by step. So here's the game plan. It's super simple. First, we'll make our first link. We'll call it node A. Then we'll make a second one, node B. And finally, the most important part, we'll connect them and make our chain. Okay, step one. We create node A in the computer's memory. We can put some data in it, let's say the number 10. But what about its special pointer, that link? Well, right now, it's pointing at nothing. It's just an empty connection, waiting for us to tell it what to do. Next up, we create node B, and let's say this one holds the number 20. It's just floating out there in memory, totally separate and independent from node A. And just like before, its own link points to nothing. So now we have two completely separate, unconnected links. And here it is, the magic moment. We take the link pointer inside of node A, and we tell it to point directly at the memory address of node B. And that's it. The chain is made. Node A now knows exactly where to find node B. We can start at A, read its data, and then just follow the link to hop right over to B. So we just built a tiny two-link chain. Big deal, right? Well, now we get to see how this incredibly simple concept builds the massive, powerful applications we use every single day. Trust me, this isn't just a nerdy programming exercise. This is the bedrock of modern software. I mean, really think about what we just did. We created a sequence, a list that can grow and change. What does that remind you of? What happens when you scale this idea up, not from two links, but to thousands or even millions of them? Your music playlist, that's just a chain of these nodes, where each song node links to the next one. Your browser's back button, it's just following a link from the current web page node to the previous one. And every time you hit undo in a program, you're just walking backwards along a chain of your past actions. This one simple idea is absolutely everywhere. And it doesn't stop there. This basic idea of a node pointing to another node is the foundation for way more complex structures. That chain we built, that's called a linked list. But what if a node could point to two other nodes? Well, then you get a tree, which is how your computer organizes files. And if nodes can point to many other nodes, you get a graph, which is what powers things like Google Maps and social networks. So when you zoom all the way out, you realize this isn't just some clever programming trick. It's really the fundamental DNA of how we organize information in the entire digital world. Let's just look at this code one last time. It's so simple, it's almost poetic, right? A box for data, and a little signpost pointing to another box just like it. This self-reference, this elegant little loop, is what gives software all of its flexibility and power.
So if there's one thing to take away from all this, it's that from these few simple lines of code, programmers are able to build these massive, incredibly complex digital worlds. It's a perfect example of how one small recursive idea can lead to almost infinite possibilities.
So the next time you skip to the next song or scroll your feed or hit that back button, just think about that tiny little pointer doing all the work. Now that you've seen the DNA, just how much of your digital life is really built on this one simple loop?